We are providing only 20% video as a part of promotion. For remaining 80%, that is 6 to 8 articles, current affairs video and general studies complete videos, please subscribe to our complete package. 1. North Korea successfully carried out an underground hydrogen bomb test. Can North Korea now launch a nuclear missile? What do we know about the latest test? Why can't the world stop North Korea? So was this really an hydrogen bomb? What can we say about the significance of this test? What do we know about this bomb? How important is the miniaturization claim? What are the stages required for nuclear test? GS Paper 2, International Relations, Nuclear Tests. Why recently in news? North Korea's claim to have successfully carried out an underground hydrogen bomb test. If confirmed, it would be North Korea's fourth nuclear test since 2006, and mark a major upgrade in its capabilities. But nuclear experts have questioned whether the size of the blast was large enough to have been from an H-bomb. UN Chief Ban Ki-moon condemned the test unequivocally, calling it profoundly destabilizing for regional security. Can North Korea now launch a nuclear missile? Despite North Korea's claims, experts are doubtful that North Korea can make a nuclear weapon small enough to fit on a missile. What do we know about the latest test? Observers agree a nuclear explosion of some kind took place, and it seems to have been a bit bigger than the last test in 2013. But not nearly big enough to be a full thermonuclear explosion that is H-bomb. Why can't the world stop North Korea? North Korea has a determination to defy both world opinion and heavy sanctions to reach its nuclear goal. Crucially, its main ally, China, has proved either unwilling or unable to help. So was this really an H-bomb? The estimated size of the blast suggests that they did not succeed in detonating a full thermonuclear device, experts say, because in that case you would expect a blast closer to 100 kilotons or more. It tentatively appears too small to be a hydrogen bomb. Depending on the depth of the test, it is possible this explosion was partially boosted, meaning it may have used a small amount of nuclear fusion. If it was a full thermonuclear device, it should have generated a seismic measurement of around 7 on the earthquake scale. What can we say about the significance of this test? Even if North Korea failed to successfully detonate an H-bomb, the test shows its nuclear program is continuing apace, a worry for most observers. If it has indeed tested an H-bomb, it would be a significant advancement of its nuclear program. Either way, it is nakedly advertising its nuclear ambitions. Earlier this year, it restarted its Yongbyon nuclear reactor, which has been the source of the plutonium used in previous tests. Condemnation has been pouring in, but experts say the reaction of Pyongyang's allies, particularly China, is crucial. What do we know about this bomb? The United States Geological Survey did say it generated seismic waves equivalent to a 5.1 magnitude earthquake, although analysts at the Comprehensive Test Ban Treaty Organization, CTO, said it was equivalent to a 4.9 quake. Working out exactly how powerful the blast was, also known as its yield, depends partly on how deep underground the test was. Initial estimates have been in the 10 to 15 kiloton range, according to Bruce Bennett, a senior defense analyst. How important is the miniaturization claim? Miniaturization is making of extremely small volume of bombs so that to place it in an intercontinental ballistic missile or a submarine-launched ballistic missile. As in 2013, North Korea claimed this was a successful test of a miniaturized device. If true, it would allowing it to hit neighboring countries, or potentially even the US. Most experts are doubtful of the claim. Whatever the truth of this test, for diplomacy it seems North Korea will not return to stalled talks involving US, Russia, China and others. What are the stages required for nuclear test? Nuclear devices are often tested underground to prevent radioactive material released in the explosion reaching the surface and contaminating the environment. This method also ensures a degree of secrecy. The release of radiation from an underground nuclear explosion, an effect known as venting, would give away clues to the technical composition and size of a country's device, and therefore its nuclear capability. What are the preparations required for nuclear tests? The test site is carefully geologically surveyed to ensure suitability. Such tests usually take place well away from population centers. The nuclear device is placed into a drilled hole or tunnel usually between 200 to 800 meters, 650 to 2600 feet, below the surface, and several meters wide. A lead-lined canister containing monitoring equipment is lowered into the shaft above the chamber. The hole is then plugged with gravel, sand, gypsum and other fine materials to contain the explosion and fallout underground. How the test will be done. The device is remotely detonated from a surface control bunker. The nuclear explosion vaporizes subterranean rock, creating an underground chamber filled with superheated radioactive gas. As this cools, a pool of molten rock collects at the bottom of the chamber. Minutes or hours after the blast, as the pressure falls, the chamber collapses in on itself, causing subsidence and a crater to appear on the surface. 2. For Make in India, first need discover and invent in India. GS Paper 2, Government Policies and Schemes. Why recently in news? Nobel laureates attending the 103rd Indian Science Congress felt the need for India to increase its budget reallocation for research and development, R&D, and lay more thrust on indigenous innovations and inventions. Nobel laureates suggested that Make in India slogan be replaced with Discover, Invent and Make in India. Before Making in India, Professor Gross said there was a need to invent in India. In order to invent in India, you should have discoveries in India, he said, adding that India should have to focus on new inventions, new technologies and new products that can compete on the world stage. Boosting of basic science. Basic science or science that is driven by curiosity is the foundation on which application and innovation can be produced. Investments in basic science today will take tens of years to translate into a better life and to translate into innovation and applications. Democracies like India need to invest in basic science with a long-term view while protecting the freedom of scientists. The way forward. India needs a cultural shifts where people should be oriented to pursuing science. A goal like Make in India also needs education to expand at least a factor of 10 since India is a huge country. India also needs to introduce financial schemes to fund young science aspirants since this can be enormously beneficial in enabling those with real talent to get into science at an early age.